Welcome to the video on TRIG story problems. Today we're going to be able to set up and solve application problems involving right triangle trigonometry. There's a couple of vocabulary phrases we got to talk about before we start going over story problems. The first one is angle of elevation, and the second one is angle of depression, and they're actually antonyms. Angle of elevation is the angle from the horizontal line, which is usually the ground, upwards towards your angle. So they have an observer at this point here. Your sight line to your object is here, and looking from the angle above the horizontal line. Notice how the word elevation goes along with above. And the exact opposite of that is the angle of depression, which from the observer to the object, your sight line from the horizontal line going down. Depression. So the words kind of tell you how the angle is going to look and what angle they're talking about within a right triangle. In order to solve for missing information in these story problems, including right triangles, first draw a picture. Second, label all known values. 3, determine what you need to find. Could be a side length or a ratio. 4, figure out what trig ratio you need to use. And 5, set up an equation and solve. The draw a picture step is very important. You need to be able to visualize what's happening in the problem. In every problem there's going to be a right triangle to draw. So let's start with the first one. A tree casts a shadow of 32 meters when the angle of elevation to the sun is 40 degrees. Find the height of the tree to the nearest tenth of a meter. Okay, so shadow should give it away. That's going to be the horizontal side length of our triangle. What makes it a right triangle is that the tree is going to be standing vertically compared to the ground, making a right angle. So the shadow is going to be 32 meters. That's going to be the horizontal side length. The angle of elevation to the sun is 40 degrees. So the sun's angle is going to be coming down this sight line here. Okay? And the angle of elevation to it is going to be this angle from the horizontal line going upwards, 40 degrees. Then it asks you, find the height of the tree to the nearest tenth of a meter. So the height is going to be the vertical length here. So they give you an angle, a side length, and I want you to solve for another angle. Let's label our side lengths. X is opposite the 40 degree sides, the 40 degree angle, and 32 meters is adjacent to 30 meters. So OA in our SOHCAHTOA mnemonic is going to be tangent. So tangent of 40 degrees is equal to x over 32. We chose tangent again because it was opposite over adjacent. So we're going to solve for x now, so that means multiply by 32 on both sides. That way x is going to be approximately to the nearest tenth of a meter, 26.9 meters tall. So we drew a picture, labeled the known values, determined what we need to find. We decided on the trig ratio depending on the side lengths, and then we set up the equation and we solved. And that's essentially what we do for all these problems, using the information given to you within the couple of sentences of each problem. Number 2, a large totem pole is 98 feet tall. On a particular day at noon, it casts a 163-foot shadow. What is the sun's angle elevation at this time? Round to the nearest tenth. So a large totem pole that is 98 feet tall. So feet tall is going to be a vertical length. And since poles usually stand vertically from the ground, it's going to be a perpendicular meeting there. On a particular day at noon, it casts a 163-foot shadow. Shadows appear on the ground, so it's going to be on the horizontal line. They're asking for the sun's angle of elevation at that time, so that's what we're looking for. So essentially you're looking for the angle that comes from the ground, the horizontal line. We'll call it theta. And again, angle of elevation is coming from the horizontal line up, so it's going to be angle of elevation. So here we have, from the angle across, it's going to be opposite. 163 is going to be adjacent. So OA, we're going to use tangent again. Tangent of theta is equal to opposite over adjacent, 98 over 163. Now, we are solving for the angle. So in order to get theta by itself, we need to do the inverse tangent on both sides. So just like we did in Finding Missing Angles notes. So tangent inverse of theta, and tangent inverse of 98 over 163. And the tangent, inverse, and tangent cancel out to leave you with theta. And inverse tangent of 98 over 163 is going to be approximately 31.0 degrees as your angle. So drew the picture, label the side lengths, figure out what we need to find, solve the equation, write the units. Moving on to number 3. On to number 5. It says, a damsel in distress is being held captive in a tower. Her knight in shining armor is on the ground below with a ladder. When the knight stands 15 feet from the base of the tower and looks up at his precious damsel, the angle of elevation to her window is 60 degrees. How long does a ladder have to be? So this is another right triangle. The vertical length is the height of the tower. The horizontal length is going to be 15 feet, because that's how far away he is standing. And the angle of elevation they give is 60 degrees. Let me zoom in here. Now, we have a 60 degree angle, and we have a 90 degree angle, which leaves us with a 30 degree angle. So therefore, we can assume that any of the 30, 60, 90 right triangle, special right triangle side length relationships will also hold here. You can still do your trig functions, the setting up the equations to solve for this, but you can also use special right triangles as well. It asks you how long does the ladder have to be. The ladder is going to be actually the hypotenuse here. So that's going to be our x. That's what we're looking for. So right now we have, in this case, the short leg going to